Hello and thank you for viewing my presentation. My name is Matt Patterson and I'm a postdoctoral researcher at the University of Oxford in the UK. I'm going to talk about some work examining the effects of tropical sea surface temperatures on the East Asian summer jet, focusing on decadal timescales. This is part of a UK Met Office CSSP China project. So why do we care about the East Asian summer jet? Variations in the East Asian summer jet are linked to changes in the summer monsoon precipitation, and that affects around 1.5 billion people, either directly or indirectly. Since the mid-1990s, there has been a southward shift of the jet, leading to enhanced precipitation and flooding over in southern China and drought conditions over northern regions. In this study, we want to understand the role that SSTs play in driving decadal jet variability. For this analysis, we are going to use the first two EOFs of upper-level zonal wind as jet indices shown on the right. Between them, they explain somewhere between 50 and 60% of the variance on decadal timescales, and they are well separated. EOF1 consists of a poleward shift of the jet, while EOF2 is characterized by a strengthening of the jet. So how might SST variability play a role in jet variations? Well, on an interannual timescale, Chu and Huang showed that the Indian Ocean basin mode, a basin-wide warming of the Indian Ocean, affects the East Asian jet via the Pacific-Japan pattern. That is, following an El Niño event, the Indian Ocean warms up as a result of changes to the Walker circulation and ocean circulation anomalies, and the Indian Ocean then heats the atmosphere in the following summer, which generates an atmospheric Kelvin wave and subsequently a Rossby wave pattern with centres of action east of the Philippines and over Japan, hence altering the jet, which is also in that Japan region. So it is possible that a similar mechanism acts on longer timescales. Additionally, the Pacific Decadal Oscillation, the PDO, has a strong tropical component and is capable of affecting the jet similarly to the interannual ENSO anomalies, again via a Rossby wave. So, I'm going to use two main sources of data to understand decadal variability of the jet and the link to SSTs. So when considering decadal variability, the observational record is relatively short, particularly when considering the upper troposphere. Additionally, there is the complication of external forcing from aerosols and greenhouse gases. Hence, in this study, we use the pre-industrial control runs from CMIP6 models, as these are sufficiently long at 500 years or more, and are not complicated by external forcing. Secondly, we make use of a set of atmosphere-only model runs following Baker et al. 2019. These are runs forced with a seasonal climatology of SSTs taken from observations, but with random perturbations imposed with scales 10 degrees in latitude and longitude. There are 5,000 ensemble members to these experiments, and they allow the sensitivity of the jet to SSTs in different regions to be determined. Finally, we will combine these two sources of information to try and understand SSTs in which regions can skillfully reconstruct the East Asian jet variability. If we take the first two EOFs of zonal wind in the East Asia region, but low-pass filtered to extract only the multi-year component, we can calculate correlations with low-pass filtered SST variability at every grid point. The top two panels show the multi-model mean of these correlation maps. It can be seen that a poleward shift of the jet, that is EOF1, is negatively correlated with SST anomalies in the Western Indian Ocean, Pacific, and tropical Atlantic. However, there is a large amount of variability in the magnitude of the correlation between different models. I've shown two here. The CNRM model shows no significant tropical SST correlation, whereas HADGEM3 shows large negative values. Now, different ocean basins may themselves be correlated, so it is not yet clear which SST anomalies are important in forcing the East Asian jet. So instead, we can use the atmosphere-only runs, which have no large-scale spatial structure to the SST, or interbasin covariability, and we can perform a similar analysis to what we did with the pre-industrial control runs to find the sensitivity of the jet to SSTs in different regions. We of course have to make a few assumptions with this analysis, so including that the ocean mostly forces the atmosphere, and secondly that the response is relatively linear. Examining the patterns, we can see that there is a good amount of consistency with the pre-industrial control runs, particularly for EOF1, with a poleward shift of the jet associated with cool anomalies in all three basins. Finally, we can combine these two pieces of information to investigate which regions are most important for skillfully reconstructing decadal jet variability using SSTs. For each model, we project low-pass filtered SST anomalies onto the sensitivity pattern from the atmosphere-only runs and plot this, shown here in red, for CESM2, along with the time series associated with the jet EOF1, shown by the dashed line. If we do this for all models and plot box plots on the right, you can see that almost all models are significantly correlated with the SST-based reconstruction, suggesting that the SSTs play a significant role in decadal jet variability. However, if we break this down further into different regions, it turns out that most of the skill comes from the Pacific, while the Indian Ocean actually adds very little skill if we only project onto those particular regions. So the Indian Ocean does not show significant correlations. To sum up, meridional East Asian jet variability on a multi-year timescale is correlated with tropical SST variability, suggesting that there is potential for predictability provided that the SSTs themselves can be skillfully predicted. Most of this skill comes from the Pacific, while the Indian Ocean is generally not so important in the pre-industrial control runs. That is not to say that the Indian Ocean may not be important when considering forced variability. Finally, future work is likely to involve testing these findings using decadal forecasts. We also have a paper on the work I've presented currently in preparation. Thank you very much for watching my presentation, and do get in touch if you have any questions, feedback, or ideas. Thank you.